Hello, welcome back to Decaf-Math ASMR, and a warm welcome if you are new here. I hope that you've been taking good care of yourself and even managing to find moments of peace and comfort, and even little nuggets of joy at this time. Today I wanted to make a more tedious or mundane or kind of boring video, just so that we can include a bit of peace in our little corner here of the world and the internet. And I wanted to encourage extra relaxation, and especially if you need it, I hope that this video can help you fall asleep. So you can follow along with what I'm saying, or you can also just zone out. I will be taking a look at this geometry tools set, this little tin box here. It's a bunch of little things inside that we can play around with. So we'll do a little bit of tapping and maybe some tracing. Just random chit chat and play. And thank you as always for being here with me. So you can close your eyes or just let your eyelids fall a bit and get heavy. So the first thing that I notice is this. This is by Staedtler. Is that how you say it? Staedtler. 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 And on this tin, I see 0, 1, 2, 3, 4. I also see a bunch of little dots. Dot. 1, 2, 3, 4, 5, 6, 7. Dot. And then let's see a bunch of lines. Fun little geometric shapes here. And a spiral. Like this. Some dashed lines or dotted lines. Circles. Lots of circles. Concentric circles. And just some random stuff here. Next, plus another spiral. Just some fun geometric shapes on this tin. Great. So now let's take a look at what's inside. I'm gonna try to do this gently, which obviously means just editing out loud sounds. And all of this stuff fits inside so nicely. It's gonna be fun to unpack together. But before we do that, I noticed that there's some writing here on the inside cover. And on the top, it's quite small, so you might not be able to see this, but it says tables with metric equivalent. So I see some weight conversions, like 14 pounds equals 1 stone. do that. Lineal measures, like 5.5 yards equals 1 rod, pole, or perch. Okay. Cubic measures and square measures, and even a couple theorems. It says theorems, etc., but there's 2 theorems and like a few formulas for areas of stuff, like the area of a triangle is half times the base times perpendicular height. And there's the Pythagoras theorem. In a right-angled triangle, the square of the hypotenuse equals the sum of the square of the other 2 sides. I think that's actually a typo. It should be equals, but there's like a E for some reason. But the square of the hypotenuse equals the sum of the squares of the other 2 sides for a right-angled triangle. Cool. So it has like a couple volumes, circumference, area formulas, just handy dandy. And then the thing on top is this cool stencil, looks like. So we have from A to Z, capital, and then lowercase a through Z, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a 0. Quite nice. I have no idea why we need all these letters in a geometry set, but I'm all for some fun stencils anyway. It's really pretty blue too. It's a really pretty shade of blue. So I can play around with this. How about this? And this is fun because this is like a cool font, because the parts that normally connect, like in the O or like B or like the R, it doesn't really connect all the way. So like R actually looks like this. There's a little gap there. You could connect it if you want to. You connect it all the way around, but leaving it with the gap actually looks kind of cool. It's like its own font, which is kind of fun. Then we have the numbers. So I don't know. I'm not really sure why this is here, but I like it. So and then I see this, which we'll come back to, I think. That's going to be fun. It's like the core of a geometry tool set, but I see this ruler right here. And it's also another really pretty shade of blue. And on one side I have from 0 to 15 centimeters, cm. And on the other side I have from 0 to 6 inches. Inches. 1, 2, 3, 4, 5, 6. So that's cool. You can do your own little conversion there. Just measure a length. This is fun texture too. I wonder if we can hear it, but yeah, I don't want to make any sharp sounds or anything. But it's really pretty. This design's really pretty. Cool. And so this is for measuring, where you could use this as a straight edge without caring about lengths, but that's nice. And then we have a sharpener, a little sharpener. It's cute, but a small sharpen. Let's see if we can use some gentle sounds. I don't like harsh pencil sharpening, but now I'll just put this on the side. Okay, I'll clean this up later. But a nice little sharpener, which is handy, and along with that, a very cute little eraser. It's so cute. I don't know what it is, but something about making things mini just makes it so cute and nice. Like things that aren't even normally nice. When you make it mini, it's cute. Like a pencil. Who cares about pencils? But a mini pencil. So adorable. Okay. So, this is nice. Yep. Confirmed. Indeed, an eraser. And then we have the core of the geometry part, I think, which is this thing, the compasses, and the protractor. So, I think, I don't actually know what this one is for, so I see here that, getting ahead of myself, that I have two pointy parts, but nowhere to put the pencil for this one, so I'm not really sure what it's for. Maybe just measuring the length or something, and then just using that to say, okay, this distance, and you can measure it if you want to, or I don't know, it's probably just to like hold it. And then the other one is the actual compass where you draw. So it comes with this wooden pencil, and this is the classic compass where you have one part that's pointy, be careful, and then this other part which you can tinker with a bit, it's kind of fun, but this is where you put the pencil in. So you go like this, and you open it out to where the pencil can fit, and then you make sure that they line up, and then you can just tighten it back. You can have some fun tinkering with this, and make sure it lines up, not like what I just did. So you can pull this back a little bit, make sure it lines up. And you can kind of just adjust it while putting it down on the paper, then tightening it back. So now you have one part that draws the circle, and then the other pointy end is for the center. So let's see here, let's see if we can do one. You put a center right here, you can pick a random radius, and then you just go whoop, all the way around. Perfect. And that is the very definition of a circle, is the set of all points that are equidistant to a center. So once you set that distance, you just plop it down and don't move it, and then you spin it all the way around. So you just put your center down, and then you set a distance, your radius, and then you plop it down and you don't move it, and then you just spin all the way around. So that's nice, and you can set your radius to be whatever you need it to be. And then, like we said, I guess this one is just to hold that length. I'm not really sure. Do you know what this one's for? The two pointy ones. Be very careful too, they're very sharp. So if you get your hands on a set like this, definitely be careful. This is kind of fun. It's like a little file too. And then we have this protractor. And so if you have done or are learning constructions in geometry, you've probably seen this before. Basically, it looks like here it actually has like a ruler part to the straight edge part from 0 to 10 centimeters. But basically this part helps us measure angles. It helps us measure the degrees of an angle, or to just draw angles. So I'm not sure if you'll be able to see this, but on this side we have 0. So on the top we have 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90 is the right angle. 100, 110, 120, 130, 140, 150, 160, 170. And then 180 is a flat. So a straight line is 180 degrees. So it's basically like having a ruler, but that's curved in this semicircle, this half circle. So from 0 to 180 this way, and if you start on this side, you go 10, 20, 30, 40, 50, 60 to 180 going this way. So it really depends on if you're starting on this side or this side, but conveniently they write out all of the angles in both directions, so that's nice. And then, like we said, we can use this as a straight edge as well, so you don't have to use your ruler if you don't want to. So this is for, let's say we have just a random angle here, so like this. So an angle is made up of two rays, and a ray is this thing that goes on to infinity in one direction. There's this point here, and then it goes off in a direction, and so this is a ray and this is a ray, and when you have them joined together here, there's a vertex, and then this kind of paints out this angle. So you'll want to designate one of them as your initial ray, but we'll just assume it's this one. And so protractors are usually clear like this, transparent. I've had some that are really cute colors, but they are all clear because we'll want to be able to see the lines that we're working with, or the rays that we're working with, so that we can line it up with the protractor itself. So if it were completely, solid, we wouldn't really be able to read through it. So we're going to line up this sort of crosshairs, this dot on the vertex, and it's okay if it's diagonal, you just pick, and then you line up that first one with 0. And in this case, since 0 is this way, let's see here, there, 0 is this way, we're going to read the bottom going from 0 to 10 to 20, 30, 40. So then we look at this and we trace it out, and just gonna make a little note right there because you can extend it to infinity, and that is about what, 30, this is 35, 36, 37 maybe. It's between 36 and 37 degrees. So this angle is about 37 degrees. So that's really cool. And you can also just use this to measure an angle, or you can also use it to draw one. So if I said draw a 30-degree angle, you just make a random side as your starting one. You center your crosshairs at the center there, and you read from 0 to 30, and you make a little note where 30 would be right here. And then you go ahead and draw that ray. And this angle is 30 degrees. So those are all in degrees, and you can translate that to radians if you want to. But yeah, we can have some fun with some constructions and stuff sometime soon. Some planning on that. And we will most likely use, for the general geometry constructions, usually you just need a compass and a straight edge, but you can also do some fun ones if you want to be more specific with angles. We can play around with this as well. So let's get this all right back into the tin. There's this little plastic holder thingy for the sounds, so we can play around with it. Actually quite nice. It's so pretty, and that's it. So we're gonna fit everything right back in. gonna do my best to get it back into how it was. Cute little eraser. This one I think just goes right here. The mysterious compass thingy. And then we have our actual compass. How does this fit? I guess I'll take the pencil out. I love this though, it's really cute. I like the aesthetic of it too. I actually still remember vividly the set that I had when I was little, and I actually still have the rulers and the pieces of it, even though now it's long all messed up, but even down to the cute little eraser. So then here's this pencil, and then let's see what else. This goes in here like this maybe. How am I doing? I remember just trying to like jam everything in, and then we'll get our stencil in here. That looks pretty good, right? Then we'll get this closed, and I don't really want to make like a loud noise closing this, but I'll just leave it like that. Beautiful. Beautiful, beautiful. Seems like a really nice set. I like this one a lot. But we'll play around with this. I got this so that we could do some fun constructions here on this channel a bit. And I hope that you enjoyed playing around with some of these tools. And if you are asleep by now, I wish you sweet, sweet dreams. And if you are not, I hope that you are relaxed and ready to carry on with the rest of your day. And I wish you peace, love, joy, patience, kindness, and I will see you around for more math.